Good morning to all. Let us start the next chapter, optics. Today in this lecture I am going to cover the following points: refraction of light, laws of reflection, principle of reversibility of light, refraction through a parallel slab, refraction through a compound slab, apparent depth of a liquid, total internal reflection, and finally few numericals based on these topics. Now, refraction of light. As you know that whenever the light travels from one medium to another, it changes its path. This change in path is because of the change in the speed of light. So, the phenomena of changing the of path by the light ray is known as the refraction of light. This already you have studied in class 10th. The laws of reflection you have studied also. According to first law, the incident ray, the normal to the refracting surface at the point of incidence, and the refracted ray all lie in the same plane. And according to the second law, that is mu is equal to sin I upon sin r, where I is the angle of incidence and r is the angle of refraction, and mu is the refractive index. This constant is known as the mu. This is the refractive index of the medium. Now, as mu of the optically rare denser medium. Now, optically denser means that the optical density and the mass density is different. For example, the turpentine oil is optically mass density is less, that is why it flows over the surface of water, while optically it is more denser than water. So mu of optically rare medium is lower and that of the denser optically denser higher. Means the refractive index of the turpentine oil will be more than the refractive index of the water. Mu of the denser medium with respect to rare medium is more than 1, and that of the medium with respect to denser medium is less than 1. In refraction, the velocity and the wavelength of the light changes. Now, as you know the relation V is equal to n lambda, where n is the frequency of the medium. So as the velocity changes, the wavelength of the light changes. Its frequency remains same. So whenever the light in refraction, the velocity and the wavelength of the light changes. Now the relationship mu of medium with respect to air is the velocity in air upon velocity of light in medium, and with the wavelength, mu of medium with respect to A is wavelength in air upon wavelength of the light in medium. Now, principle of reversibility of light, that is, if a ray of light after suffering many number of the refraction, then its path reversed at any stage, it travels back to the surface along the same path in the opposite direction. That is, if with the help of a mirror, if its path is reversed, then it will retrace its path. So by concluding, then we can say that if we change the position of the object and the image, then it will not make any change in the path of the ray of light. So these two positions are called the conjugate positions. Now, refraction through a parallel slab. Now this is a glass slab. If this light is falling on this surface, then because of the slab, it reflects back not to the original line, but there is a lateral shift in the ray of light. So mu of this is the denser medium B and rare medium is A. So we can say mu of B with respect to A is equal to sin I1 upon sin R1, and mu of A with respect to B, यहाँ से mu of A with respect to B is equal to from here sin I2 upon sin R2. So when you multiply this, since this multiplication is 1, so this will also equal to 1, and this will be possible only when I1 is equal to R2 and I2 is equal to R1. That is, these two angles should be equal and R2 is equal to I1. So there will be a lateral shift because of this. The value of the lateral shift is y is t sin del upon cos R1, or y is equal to t sin I1 minus R1 upon cos R1. The derivation of this relationship is not in your syllabus. Now, if I1 is very small, then R1 is also very small, that is sin I1 minus R1 is equal to I1 minus R1 and cos R1 is equal to 1. In that case, the y, that is the lateral shift, is equal to T I1 minus R1. So this is when angle I1 is very less. Now apparent shift or apparent depth of a liquid. This you have observed in your daily life, that whenever you see through the river, then the pebbles under the bed, they appears to be raised. So why they appear to be raised? This is because of the phenomena of the refraction. So let us see how much the apparent depth is appears. So let us consider that this is the object or the coin placed in a glass of water or in a water tank. Now, when you observe it from the rare medium, that is from the air, this is the denser medium, which is the liquid in which the coin is immersed. So mu of A with respect to B, that is mu of this rare medium with respect to B, that will be sin I upon sin R1, as the ray is coming from the denser medium. So refractive index of the rarer medium is equal to sin I upon sin R, or on reversing it, mu of B with respect to A is equal to sin R upon sin I. Now, if you find out the value of sin R and sin I from this triangle, let us give the name. At this point is equal to A and this point is equal to B. Now from this triangle, if you find out the sin R is equal to perpendicular upon hypotenuse. So from here sin R is equal to O dash B upon AB, and sin I is OB upon perpendicular upon hypotenuse. So AB upon O dash B and AB upon OB. So when you put these values, the result will be equal to OB upon O dash B. Now when you are looking at the object from the rare medium, then both the rays should enter into the eye, and this will be possible when B is near to A, and in that case we can say that OB is equal to OB is approximately equal to the real height, that is the HR, and O dash B is approximately equal to the apparent depth, that is O A. So when you put these values in this relation, you will get the relation, that is mu B of B with respect to A is equal to real depth upon apparent depth. So this is the relationship, that is the mu of the denser medium in which the object is kept is equal to the real depth upon apparent depth. Now if you find the relation apparent depth of number of immersible liquid, means if you have only in place of water there are 2-3 liquids which are not mixing, then in that case the apparent this is the apparent height will be equal to summation I is equal to 1 to n hi upon mu I. Now apparent shift, naturally apparent shift will be equal to, that is apparent shift will be equal to the real height minus the apparent height. So from here you can get HR into 1 minus 1 upon mu. Now if the observer is in the rare medium, as in this case which we have discussed, then the object is in the denser medium, then apparent depth is less than HR. So from this we can conclude that to a bird which is in the air, the fish which is in the water, that is the denser medium, will appear to be nearer than the actual depth. And while for the fish, since fish is in the denser medium, so the bird will appear to be farther than the actual height. So this is the difference because of this, the phenomena of refraction. Now let us discuss the total internal reflection. Now as you know that if any ray from the denser medium is moving towards the rare medium, then it moves away from the normal. So let us see that this incident ray, it is away from the normal. Increase the angle of incidence, then angle of reflection will be more. slightly increase the angle of reflection, then one time will come when the angle of reflection is equal to 90 degree. So the light ray, instead of traveling to the rare medium, it will be parallel to the interface, and if the angle is increased, then instead of going to the rare medium, it will come back to the denser medium. So this phenomena is known as the total internal reflection. So it is the phenomena of the complete reflection of the light back into the same medium for the angle of incidence greater than the critical angle of the medium. So the conditions for the total internal reflection or TIR, that is the incident ray must be must be in the optically denser medium, or we can say that the ray should travel from the denser medium to the rare medium. The second condition, the angle of incidence must be greater than the angle of critical angle for the pair of medium in the contact. Now for the pair of medium in contact, because the critical angle will change as the pair of the medium will change. So the relation between the critical angle and the refractive index. Now critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rare medium is 90 degrees. So if mu of air with respect to glass, then sin n upon sin r. When I is equal to sin IC, then r is equal to 90. So sin IC upon sin 90, and that is equal to sin IC. So from here again, mu of glass with respect to air can be changed. Mu of glass with respect to air is equal to 1 upon mu of air with respect to glass. So we can say that mu of glass with respect to air is equal to 1 upon sin IC, or sin IC is equal to 1 upon mu of glass with respect to air. So usually the denser medium in the absolute refractive index, so we can, in place of mu of glass with respect to air, we can use the word mu. So mu of is equal to 1 upon sin C, where C is the critical angle. So either write IC or sin C. So mu is equal to sin C. This is the relationship, or we can say that sin C is equal to 1 upon mu of the denser medium. Now again, mu is equal to lambda in terms of the wavelength. So it can be written as lambda in glass upon lambda in air. That is the wavelength of the light in glass upon wavelength of light in air. Now since red has the maximum wavelength, so from this relation we can say that the value of the critical angle is maximum for the red color, and for the violet color the value of critical angle is minimum. And from this relationship we can also deduct that we know that mu is also given by the Cauchy's relation. Cauchy relation is A is equal to B upon lambda square. So 1 upon mu in that case also, since lambda for the red color is maximum, so mu will be minimum, and mu is minimum means critical angle is maximum. So value of the critical angle is maximum for the red color and minimum for the violet color. Now, and the application of the total internal reflections, they are very important. Now the mirage formation, that is in the deserts, it appears that there is a water tank as the traveler find the inverted image of a tree. Glooming is also the same thing, that is कहीं कुछ आभास होना, just like in the summer season when you move on the roads you see the patches just like the water is on the road. So that is the glooming. The total reflecting prism are also based on TIR. Optical fibers, the sparkling of diamonds, all these are based on the total internal reflection. Now these are few numericals which are based on the topic taught today. So solutions are also given. Go through the questions and solutions. If you have any problem, you can discuss at any time.